Okay, so on number 13, you're looking for a couple of techniques. One is if there's a single variable in the denominator, you'll want to move it up and then integrate. So unlike letter A on number 13, you would move the x to the fourth up and make it x to the minus 4. And then you've got minus x to the fourth, and then minus 1/4, and then dx. And then you can kind of individually take the integrals of each of those and then do the plus c at the end. So remember, when you integrate, you add 1 and divide. So I add 1 to -4, making it -3, and divide by -3. And then add 1 and divide by that power. And then 1/4 would just be 1/4 x, and then plus your c, since it's an indefinite integral. For letter C, another technique is if there's one variable in the denominator, split the fraction up. So this is u over the square root of u, change that to the 1/2 power, plus 1 over u to the 1/2 du. All right, so if you've got u to the 1 on top and u to the 1/2 on the bottom, you subtract the powers and go to the side of the bigger one. So that would be u to the 1/2 on top, because you've got 2 halves and 1/2 on the bottom. The dude on the bottom needs to move up and become u to the minus 1/2. And then, just like before, add 1 and divide. So add 1 to 1/2 is 3 halves. And then divide by 3 halves, but then that's the same as multiplying by the flip, 2/3. Add 1 to -1/2. So that's going to become positive 1/2. And then again, divide by 1/2 is the same as multiplying by the flip. And then plus c. The other thing is you're looking for like u substitutions, and that usually comes in the form of a power. So whatever's raised to a power, you might want to consider doing a u substitution on. So like letter E, I'd pull that 12 out in front, sine x, and then that's cosine to the 5th x dx. So if I let u equal cosine x, okay, I'm going to have to go stop the dog from barking. Hold on. Okay, so I don't know if this worked or not, but we'll keep going. So we've got u equals the thing being raised to the power, du, the derivative of sine, or derivative of cosine is minus sine x dx, which is good because I have a sine x dx. And that's just another name for du. So I've got the 12 hanging out in front. Cosine to the 5th x, well, cosine x is u, so that's going to be u to the 5th. And then sine x dx is, we'll divide off by -1 here. Sine x dx is du over -1. So I'll pull the -1 out in front, so 12 divided by -1, u to the 5th du, or -12, and then go ahead and integrate u to the 5th. So again, you add 1 and divide, u to the 6 over 6, and then we don't do the plus c just yet because you got to substitute back in cosine x. So this is -12 cosine to the 6x over 6 plus c, and then you can reduce down -12 6 to -2. Trying to see real quick here. On letter F, find an antiderivative, so it's that thing, of -4/5, pull that out in front, cosecant squared x over 5 dx. So I think I'd let u equal the inside thing. No. That must be some sort of trig or integral. I don't do cosecant squared x, so you might have to look that integral up. I think that's just an integral of something, gives you back. I'm not seeing it. Cotangent x maybe, or something. That one you're going to want to look up what the integral of cosecant squared is. I'm not 100% sure on that one at all. Let's see, letter D. Now, letter D, again, I'm seeing like a bigger power on the bottom, so you can't split that integral up because there's two terms on the bottom. You know, so we can't just split it up and reduce it down or something. So again, I would be thinking of letting u equal that whole bottom there, because if I take the derivative of that, it's going to equal 6x squared, and then multiply both sides by dx, so du equals 6x squared dx. And that's good because I have an x squared dx, but I don't want the 6, so I'm going to divide that off. So when I do my substitution, this is the integral of du over 6, which is the x squared dx, times, and then this is going to be 1 over, and then the u is on the bottom, du. Whoops, I already got a du in there. So pull the 1/6 out in front, integral of 1 over u du, which, if I remember right, that might be a natural log. And then plug in the 2x cubed plus 1. And then plus c. I'm not checking my answers here, so I'm hoping that's right. All right. And then let's just stop here because it's going to be a really long video.